Hello everyone. Today we are going to see about, let's continue conditional probability. We'll start with axioms. Axioms means some rules. These are the basic rules. The first one is the set of all possible events. The probability of, this is the probability set of all events should equals to 1. And you know these things in basics, like mutual exclusive. There is no interaction between event 1 and event 2. So it is called mutual exclusive events. So this is 5. There is nothing inside the sample space, that is null set. The probability of mutual exclusive events is always 0. So that's why P of E1 union E2 is equals to P of E1 plus E2. And we know addition rule. The addition rule is like P of A plus P of B minus P of A intersection B. And I'll teach more about why we minus P of A intersection B. Okay. And there is a problem. A contamination has low, high in total, which has center and edge contamination and center contamination. Let's see. Let C will be center contamination and H is high contamination. He wants to find probability of C union H. What is the formula C union H? P of C plus P of H minus P of C intersection H. What is P of C? P of C is favorable condition by total. This is P of C. 626 divided by total 940. What is H? H denotes this one. 358 divided by out of 440 minus, this is the intersection point for center and high, that is 112 divided by 940. 940 626 plus 358 minus 112 will give one second. How much? It's 872 by 940. Here we are eliminating intersection. How? We are taking center once, 626, whereas we are taking high one here. Again, it is coming 112. So 112 is repeated twice. That's why we are just eliminating once. That's it. That's why we are eliminating one intersection point. And next, one more question. A box contains 8 white balls and 12 black balls, and another box contains 12 white balls and 13 black balls. Total 25, and here 20. So what is the probability that ball is white? The condition is white ball. First, we need to select one box out of 2. There are 2 boxes. First, we need to select one box out of 2 boxes. And now we are going to select white ball. Here, this is selection, right? Yes, 8C 1 ball out of 20C 1, or 12C1 out of 25C1. That is 1 by 2 into 8 by 20 plus 12 by 25. As we discussed in the previous class, and this is OR. First, we are selecting one box out of 2 boxes, and we are selecting white ball from first box or white ball from the second box. Okay. Okay. Let's go into topic conditional probability. Very important topic for your examination. So kindly focus on this. Conditional probability. Here, to describe or to build a conditional probability, one event must dependent on B. If those are independent events, I'll that we cannot apply conditional probability. The conditional probability is one event should depend on another event. So P of A given B is P of A intersection B divided by P of B, where B is known event. Out of two events, one event should be known. B, this is unknown event, where P of B should not equals to 0. So conditional probability P of A given B is equals to P of A intersection B divided by P of B, where B is known event and A is unknown event. What is multiplication rule? We have seen addition rule. This is multiplication rule. P of A intersection B, that equals to P of A given B into P of B. Like just P of A given B into P of B equals to P of A intersection B. This is how it came. So this is multiplication rule. This is very important note. If A and B are independent events, like as I said earlier, what if both events are independent? If A and B are independent, then first condition P of B given A is equals to P of B. And second condition, as P of A given B is equals to P of A. And very important condition, third, P of A intersection B is equals to P of A into P of B. Okay. Here how, like this P of A given B becomes P of A. So simply P of A into P of B. So this is very important condition. And you might expect this type of questions in coming examination. Focus on this problem. This is very important problem, and I have seen many questions from examination. He has given some table. There is defective, non-defective. Out of surface flaw is also defective. This is F. Surface flaws S and no. Okay. Let P of defective S is P of D and no is P of D dash. And let's say this is F and this is F dash. Okay. I'm going to define what are these numbers are. The 10. Number 10 is D and F. This is very important to write down. This is D and F. What is this 30? This is D dash and F. Similarly, this is F dash and D, and this is F dash and D dash. Okay. What is P of D? P of D is 10 plus 18 out of, this is total. We can't change the denominator always, 400. That is 28 by 400. Okay. And P of D dash is 30 plus 342 divided by 400, that is 372 divided by 400. Similarly, P of F is 40 by 400 P of f dash is 360 divided by 400. Okay. Let's find out P of f given D. We know that P of f intersection D divided by P of D. P of f intersection D. P of f intersection D. Where is P of f intersection D? This one. That is 10 divided by 28. Okay, let me write another step. 10 by 400 whole divided by 28 by 400. 400 will cancel. 10 by 28. P of f dash given D. Where is that P of f dash intersection D divided by P of D? P of f P of f dash intersection D. We can find out. I'm sorry, this is this one. That is 18 divided by P of D 20. That's it. Very simple. And these type of problems will appear in examination. That's why I'm telling again. Find out what is 10. This is D, F. D and F. So that's why it is intersection. Okay. This is D dash and F. D dash intersection F. 18 is F dash and D, F dash and D dash. So let me find P of D dash given F dash. We know that P of D dash intersection F dash divided by P of F dash. What is P of D dash intersection F dash? This one. 342 divided by F dash. 360. That's it. Okay. There is a simple problem in a class of 30 students like T. T is 0.3 and coffee is 0.2. 10% both. Okay. A student randomly selected what is the doesn't like T, knows that he is, so he doesn't like T, that is T dash. He doesn't like T and he likes coffee. This is what that is. Find out the area. This is T. This is coffee. So T should not come inside the coffee. That means this area. We need to find out that area. P of T is 0.3. P of C equals to 0.2. P of T intersection C is 0.1. Okay. P of T doesn't like T. T dash given C. We know he likes coffee. So that's why known event is in denominator. P of T dash intersection C divided by P of C. So we need to find out this area. We know that this is 0.2 out of, 20%. Out of 20%, he occupied 10%. The rest area is 10%. The whole circle, the whole coffee is 20%. The intersection part covers 10%. So the rest area is 10%. That is 0.1. The 0.1 divided by P of C, how much? 0.2. That equals to 1 by 2. Okay. Next is about Bayes theorem. This is also one of the conditional probability, but here what we study in BTech is completely different in masters. Like the application of knowledge is different from BTech knowledge. Here, what I use, this is the technique I have used by Dr. Fred. He uses some diagrammatics. So using this diagram, I will write Bayes theorem. From this diagram, there is a event, a large event, B. It is divided into some groups, B1, B2, B3, B4. And an event A is merged inside B. So A is completely dependent on B. As we know, don't remember all these formulas. Try to find out even in the examination. Like P of I need B given A. From the conditional probability P of B intersection A divided by P of A. Isn't it? Or shall I write A intersection B? P of A. P of, from multiplication rule, P of A given B into P of B divided by P of A. So this is from multiplication rule, as we discussed earlier. So B given A. This is Bayes theorem. That's it. There is nothing in Bayes theorem. The Bayes theorem is derived from conditional probability. So I need to find out P of A. So P of A given B intersection P of B. P of A is merging with B1, B2, B3, and B4. That is P of A intersection B1, this part, plus P of A intersection B2, plus P of A intersection B3, plus P of A intersection B4. Oh, finally, I can write P of A given B from multiplication rule. I can write P of A given B1 into P of B1, P of A given Bn, P of Bn. This is Bayes theorem. If you learn these type of like formula formation, you can use any formula from any step based on the question he asks. Let us see total probability rule. Same as before. There is an event. Half is A and another half is A dash. So B is an event which is known event which is inside A. Okay. How we can write B? I need B. How can I write B? B intersection with A, this part, plus B is again intersecting with A dash. This is total probability. That's it. We no need to remember all those formulas. Simply draw an event, draw a known event inside that. So we need this one. For example, this is X, this means X dash. I need Y, Y intersection X plus Y intersection X dash. That's it. This is total probability rule. And you can directly get like there is B intersection with E1 and B is intersecting with B2 and so on. B is intersecting En. So from multiplication rule, I can write it as P given E1 into E1 plus P given E2 into E2 and so on. P B given En into En. This is total probability rule, very, very important. And final concept in today's lecture, series circuit and parallel circuit. From this diagram, we can directly say that if it is input, this is output, the signal should transfer from A and B. The AND word is very important. Whereas here the signal can transfer either A or B. So whenever you listen and that is intersection, whenever you listen or that is union. That's it. Simply like this is P of A and P of B. This is P of A or R means union, right? P of A minus P of A intersection B. That is P of A union R. This is P of A intersection B. This is unruled, this is R rule. That this is unruled, this is R rule. That's it. Circuit diagrams. Okay. Let's do one very important problem from Bayes theorem. If you have any issue with visibility, kindly let me know. I don't know how it is. Problem has given that probability of failure 0.1, 0.005 and high and not high. Probability of level 0.2, 0.2. Okay, let's denote, let H denotes high level. Please listen carefully. This is very important problem. F is failure. This one failure, and H is level of high level. I mean this one. F is this one. This is H. This is F. Okay. What he wants to find out, P of H given F. We know the formula. P of H intersection F. P of F from probability rule. I mean conditional probability. P of H into P of H given, sorry, F given H divided by P of F. This is all. This is from multiplication rule, as I said earlier before. So the challenging part is I know P of H. I know F given H. The part is P of H is P of F. I need to find out this. So simply draw a table. It's like a rectangle. This is H. This is H dash. I need F. This is F. How can I find F? F intersection with H as well as F is intersection with H dash. That is P of F intersection H plus P of F intersection H dash. P of F given H, P of H plus P of F given H dash into P of H dash. Okay. Let us insert all the values. P of H given H, P of F given H. That means this is P of F, P of F, and this is given H. What is the value? 0.1. Remember, that is probability, not the value. He has given probability directly, 0.1. P of H. P of H is this one, this line, this one, 0.2. P of F, I mean this line, and H naught, 0.005. P of H naught, 0.8. After calculating 0.24. This is P of F. So from equation 1, P of H given F will be P of H. What is P of H? This one, 0.1. P of F given H. I'm sorry, this is 0.2. Sorry. And this is 0.1 divided by 0.00. After calculating, you'll get 0.833. This is very important question. Simply, I inserted values from the table. I'm just calculating Bayes theorem. I'm not directly written P of H given F, P of H intersection F by P of F by H1, something that I don't want to do all those things. Simply remember this technique. A group contains equal number of men and women. Out of group, 20% are men, 50% of women are unemployed. If a person selected from the group, what is the probability of selected employees being employed? So this is based on total probability rule. This is based on total probability rule. So in a society, this is society, group exactly half are men, half are women. That is 50% are men, 50% are women. He has given equal number. Out of 100%, there is an event that is unemployment. 20% are men are unemployed. 50% of women are unemployed. If you know how to draw this one, easily we can find out. What is the question? What is the probability of selected person is being employed? We need to find out employee. Means this area, the green color area. First, we will find out unemployed. Probability of unemployed. It is very difficult to find out the rest area. This one. So I am going to find out the unemployment area and simply I am subtracting from 100%. As we know, unemployment, unemployed intersection men and P of unemployed intersection women. What is unemployed and men, right? P of unemployed given men into P of men plus P of unemployed given women into P of women. What is P of unemployed and being a woman? Sorry, men 0.2. Probability of men is 0.5. We know. Being an unemployed and woman is 50%. 0.5. As we know, woman is 0.5. After calculating 0.35. We know probability of unemployed. Probability of employee is equals to 1 minus P of unemployed. That is 1 minus 0.35. That is equals to 0.65. Okay, there is a big problem. Okay. We have 10 more minutes. If you have any doubts, please let me know now so that I'll decide whether I have to tell this problem or not. Any questions up to now? Or else any repetition as of now? Okay. Okay. Then okay. Let's see this problem. If you understand this problem, everything will be easy. The chances that Dr. A diagnoses a disease X correct is 60%. Probability of correct is 60%. That is 0.6. The chance that patient will die by his treatment after correct diagnosis. That is P of die after correct diagnosis. We know correct means, that's why I am writing correct in the denominator given. That is 40%. That is 0.4. The chances of death by wrong diagnosis is P of wrong is 70%. That is 0.7. Wrong diagnosis and died. die of wrong. One second. One second. He is not giving this one. Death by wrong is 70%. Sorry for that. 0.7. He has not given P of wrong. We know that 1 minus P of correct. That is 1 minus 0.6. That is 0.4. Okay. This is given data. What is the probability that the disease was diagnosed correctly? Correct diagnosis, but unfortunately he is dead. So he wants to find out. This is given it. We know that. How can we write P of correct into P of justly simply inverse it. P of die and correct divided by denominator will come in denominator P of die. Okay. We know P of correct 0.6. P of die and correct is 0.4. So we know the numerators. No problem. 0.6, 0.4. I need to find out P of die. As I said earlier before, first draw a table. I mean a box. Correct, wrong. Die. I need die. Die is intersecting with correct as well as die is intersecting with wrong as well. From multiplication rule, P of correct into P of die. Some people might get a question why I shouldn't write P of die. P of die first and P of correct given die. We need to see the question and the given data. We have die given correct, not P of correct given die. So based on the question, we have to adjust whether correct first or die first. P of correct and P of die correct and P of wrong, P of die wrong. What is P of correct? 0.6 into P of die and correct 0.4 plus P of wrong is 0.4. P of die and wrong 0.7. After calculating this, it makes 0.24. This is 0.28. Okay. Let's substitute this in this formula. 1. P of correct is 0.6. P of die and correct is 0.4 divided by 0.24 plus 0.28. After calculating this, 0.46. Bayes theorem is the simplest problem in entire probability and statistics. Directly we can use this diagram method. I have learned this technique from Dr. Fred Tayari. This is very simple rather than remembering all those formulas. So I have only 4 minutes of time. There is the last concept, that is random variables. It is very simple. Random variable, the name itself says that something is varying and we are going to denote it. So variable associates a number with outcome of random variable. Here the experiment gives different types of outcomes. That's why we are going to give a variable which can take all those vary values. So the variable values is of two kinds. Sometimes the value is like discrete random variable. Discrete means the exact value, the finite value. If the random variable with finite range, that is discrete random variable. If the variable gives you in a range from 2 to 4, 2 to 3. If you find out something called range, that is continuous random variable. I have mentioned these points in the first video. If you have finite number of values, if you are able to count it, if the values are discrete, that is discrete random variable. If the values are continuous, if you are not able to calculate the exact value rather than you're just giving the range, that is continuous random variable. These definitely you'll get a question from these concepts in coming examination. Like he'll give some values, whether is it discrete or continuous. For example, number of scratches on a surface. We can find out number of scratches on a surface. So that is discrete. Portion of defective parts out of 1000 tested. We can calculate, we can find out. Whereas in continuous, simply it is units. Units of pressure, temperature. The value which has units, that is continuous random variable, which has no units, that is discrete random variable. This is from my side. If you have any doubts, kindly let me know, or else I'll be here at 4 to 3 to BECC up to 6 o'clock. You can text me or you can email me. That's all from my side. We have finished second unit and let's see third chapter in coming video. Anything else? Any doubts?
No, Vishwa.
Thank you so much.